Okay, this question, a circuit is given and we would like to find the values of I1, I2, I3, and I4. Okay, very good. Yeah, so again, we can use KVL and KCLs. So by just looking at this circuit, I see a voltage here, some voltage is given, and then resistor here. So for KVL, again, you have to look for loops. Okay, I will prefer basically this loop, and then we have to also do something about this short circuit, rather than the loop that considers the current source, because for the current source, I don't have its voltage. Okay, but if I come here, it's gonna be better. But also somehow this this short circuit somehow catches my eye. And when you have this, as you know, and this is also the continuation of that. So if you look at this R here, this 20O, it's connected to wires. It's short circuited. So therefore, first thing that you can do somehow, basically you can just eliminate this. If this is as if it's disconnected. So somehow your circuit even becomes simpler. And by doing that, also just we can do just simply this I4. So what would be the value of I4? The value of I4 would be, hopefully everybody sees, it's gonna be 0. And the reason is that, again, because this current is short-circuited, as if it's basically disconnected. No current can go through that. The current would go around it, okay? Or in other words, as we cross it, as if it's disconnected, so its current would be 0. So that was very, very simple case. So I4 is 0. Now let's look at let's write a KVL. So KVL, again, on that loop, this loop. So I start from here and I go up, okay? So remember, I also told you in the class, so first you look at the polarity of the element. So it's a minus, negative. And then whatever its value. Whatever its value. Okay, so if for example, as if it was V1, we would just write negative V1, right? So now the V1, the whole thing, the value is negative 10. Okay, so I hit a negative, and then the value was negative 10. Okay, very good. So negative 10, and then you come here, plus 20 I1 plus 10 I2. Okay, and then again you come here because it's a short circuit, equal to 0. Okay, you come back to this one. So that's one equation. And then the next equation, it's gonna be a KCL here. So let's write a KCL. KCL, as you know, the summation of the currents going out equal to 0. So I2 is going out. I1 has to be negative I1. And then 5 amp is here, so negative 5 amp is going out. So negative 5 equal to 0. Okay, two unknown, two equations. Let me somehow simplify this. So this gives me 20 I1 plus 10 I2 equals to, this is 10, but I took it the other side because negative 10. And this one gives me negative I1 plus I2 equals 5. So two equations, two unknowns. As you know, you can do replacement. For example, you can just multiply and just add them, multiply by something. So let me do this. So I multiply the second one by 20. The reason that I want to make it 20 I1, so it becomes negative 20 I1. So this equation can be rewritten as negative 20 I1 plus 20 I2 equals 100. Okay, And then if I add this equation and that equation, 20I1 and negative 20I1 just eliminates. So then we get 10I2 and then 20I2, which is 30I2. And then you have 100 and you have negative 10, you get 90. So therefore, I2 becomes 90 over 33. Okay, very good. Now that I have I2 3 amp, I just replace it here. So you saw negative I1 plus I2 equal to 5. Now I2 is 3. So I1 is equal to 3 minus 5, which is negative 2 amp. And it's totally fine to have a negative current, negative voltage. Depends on the polarity and direction. So now I1, which is negative 2 amp. So if I1 is negative 2 amp, it means that the actual current is 2 amp the other side. Okay, very good. So I got I1, I got I2, I got I4, which was 0. Now, okay, the another part, which is I3. So what is I3? That's also an interesting part of the problem. Okay, so to find I3, again, remember this R20 is just disconnected. R3 is I3 current comes here and it goes there, continues to this element. So somehow, if you look at I3 is nothing but just I1. Okay, this is one way of seeing that. There are different ways of seeing that, or you can just simplify this circuit here by removing the 20. If I just remove 20, so this was the 10, and then I remove the 20, so somehow these are all one node. It comes one node here, continue to that element that just had this, and then this is 20, this is I1, remember, and then we have the 5 amp. So we have something like this, and now see the I3 is the current, which is, again, all this blue is 1 point, so I3 goes here, so this is I3. This is I3, which is the same as I1. So I3 equals I1, and it is negative 2. Okay. So therefore, when you are looking at circuit, just make sure you don't miss the short circuit parts. So here, this was obvious short circuit, which makes the 20 ohm basically disconnected. And the current does, and this becomes just one node. Then it continues here, so I3 equals I1. Or you could also look at here. So if you look at I2 was coming to 10 ohm. So this is still I2, which is 3 amp. And this is 5. So if we write a KCL here, you see I3 plus 5 minus 3 equal to 0, and I3 would be negative 2. Okay, so you can also write the KCL. So I put the OR here. Or we're just going that I3 equals I5.